You're looking at a multi-million-dollar corporate plaza. The stone pavers are precisely laid, the mature trees are perfectly spaced, and the entire site feels like a seamless piece of art, until a heavy excavator tears right through it. 4 months after the ribbon cutting, the beautiful hardscape is ripped apart to reach a crushed fiber optic cable. This happens when the team designing the physical site and the team designing the digital network work in complete isolation. The landscape architect plots the trees and walkways, while the IT engineers draw straight lines for data cables on a completely separate set of blueprints. Treating the physical environment and the digital network as two separate realities guarantees a collision. And that collision results in massive financial losses, torn up concrete, and delayed handovers. The moment telecommunications conduits leave the highly controlled interior of a building, they hit the Wild West of the site plan. Suddenly, a fragile data network has to survive unpredictable soil grading, heavy vehicle traffic, and deep root systems. The only way to bridge that gap is through the Telecommunications Industry Association, or TIA, standards. These regulations provide the exact physical parameters needed to harmonize delicate synthetic networks with heavy organic landscapes. TIA standards provide the hard technical data required to ensure that the physical site remains operational and accessible long after the contractors leave. Let's track a network from the inside out. Inside a commercial building, standards like TIA 568 and 569 dictate exactly how cables navigate the architecture. For fiber optic cables inside a conduit, the rules are rigid. To prevent the glass fibers from snapping, the bend radius of the conduit must be exactly 10 times its internal diameter. You cannot bend it around a sharp right angle. But watch what happens when this precise geometry exits the building. The wide fiber pathway immediately collides with heavy fire lanes and dense hardscapes designed with any thought to the network. If the site designer doesn't coordinate the routing depth with these exterior features, the weight of a passing fire truck or a heavy stone installation will easily crush the shallow conduits. Mastering the IT standards inside the server room is completely useless if the transition into the exterior environment is designed blind. When we move into sprawling land developments and estates, the primary threat shifts from heavy concrete to living, organic elements. This is where TIA 758 comes in. It regulates customer-owned outside plant infrastructure, laying down strict rules for conduit routing, burial depths, and utility separation outdoors. This section of TIA 758 standard shows the specific environmental mitigations required to prevent water accumulation and structural failure. It mandates an underground drain slope of no less than 10 millimeters per meter and strictly limits how many 90-degree bends can exist between pole boxes. But even if you get the slope and angles right, there is a hidden, slow-moving threat. Tree root systems are incredibly strong, creeping powerfully through the soil in search of water and space. If a landscape plan specifies a mature tree directly over a primary fiber trench, it sets a fatal timeline. Over a few years, those roots will intrude into the pathways, crushing the conduit and causing a total network failure. In a clash between living nature and static, uncoordinated data networks, the network will always lose. The stakes rise even higher in specialized environments like data centers and educational campuses, which are governed by TIA 942 and TIA 4966. At Tier 2 and above, the physical terrain functions as an active security asset, with topography and setbacks engineered to mitigate specific infrastructure risks. This page from the TIA 942 standard shows the extreme spatial requirements needed to guarantee continuous service during a catastrophic failure. Redundant entrance pathways must be physically separated by a minimum of 20 meters, or 66 feet, along their entire route. Site grading, security berms, and entrance roads have to be specifically sculpted to accommodate this massive separation zone. You can't just dig 2 trenches next to each other. Massive educational campuses face similarly rigid spatial demands to ensure widespread connectivity. This summary of TIA 4966 outlines the exact wireless access point density and occupancy calculations required to keep students online in large places of assembly. In these high-stakes environments, every berm, fence, and access road is a calculated component of the network's physical defense layer. A fully integrated TIA-compliant site cannot be retrofitted into existence. It has to be programmed from day zero. A truly integrated corporate plaza relies on a subsurface layout where conduits and root systems are mapped into the same spatial logic. Structurally, this means redundant fiber lines are cleanly separated by 20 meters. Sweeping 10 times bend radii are safely routed far away from deep root zones, and hardscapes are properly reinforced to protect the pathways below. Architects, landscape designers, and IT professionals must break down their planning silos and start working off the same map. Integrating TIA standards during the very first schematic design phase is the only way to ensure a project is permit-ready, cost-effective, and permanently future-proof.